So this will be the second lesson of your histopath, the decalcification class. Now, decalcification class is usually done after fixation and before infiltration on bones, teeth, calcified tissues. So decalcification class is not done all the time. It's only done depending on the type of sample. The sample has to have such high amounts of calcium, such as the bones, the teeth, and calcified tissue. Tuberculous lungs and arteriosclerotic vessels are usually done on them, as well as calcified tumors, malignant ones. Then most decalcification in washing out in water is needed to avoid erroneous stain uptake. So once you're done with decalcification, you need to wash it out thoroughly with water glass to avoid erroneous stain uptake. Ang mga decalcificating agents nyo kasi class, they have a tendency to uptake stains. So that could affect the the staining procedure. So kailangan nyo talaga siyang ma-wash out properly. Then the nucleus is slightly stained and cytoplasm would appear brick red in color. Now the principle of decalcification would follow: hydrolysis of calcium salt, releasing calcium ion, removal of calcium ion by different methods. Now, what are the methods of defalsification? The first one is the use of dilute acids. So most of the time, class, ang mga decalcification agents nyo are acidic in nature. The most common one, the routinely used, is your nitric acid. Now, your nitric acid is a very rapid decalcifying agent used in urgent biopsies. Now, nitric acid, particularly 5 to 10% nitric acid, would produce minimum distortion and is a good nuclear stain. Easily removed glass by 70% alcohol. Has a yellow color produced by nitrous acid. Then meron siyang mga variation. It would be 5 to 10% nitric acid, 12 to 24 hours ang kanyang decalcification. Formal nitric acid, which would require 2 to 7 days, Perennis fluid, 2 to 7 days, and fluoroglucine nitric acid, 12 to 24 hours. And another dilute acid you could use is hydrochloric acid, specifically 5% hydrochloric acid. This is slower than nitric acid class, gives greater distortion of the tissue, such as your von Ebner's fluid. Now, si von Ebner's fluid class is moderately rapid, used for teeth and small pieces of bone. There is no need to wash out. So, ang advantage ng von Ebner's fluid nyo, which contains hydrochloric acid, is hindi ka na need mag-wash out. Then another one is your formal nitric acid. This is also rapid class and produces less distortion than 10% nitric acid, but is known to produce a yellow stain. Then we have your Perennis fluid, used routinely, produces no tissue maceration due to chromic acid and alcohol. This is a good nuclear and cytoplasmic stain, but it is a slow decalcifying agent. Cannot be chemically tested completeness of decalcification. So, hindi mo pwedeng i-verify yung completeness ng decalcification. Then another one is your fluoroglucine nitric acid, the most rapid but has poor nuclear staining. Also produces a yellow stain. Formic acid chelates the calcium. It is a fixative as well as a decalcifying agent. Has moderate acting decalcifying agent. Safer than nitric acid and hydrochloric acid. Then we have your sulfuric acid. This is a weak decalcifying agent used for small pieces of tissue. Then you have your chromic acid, a fixative as well as the decalcifying agent. So pakitandaan lang sa si chromic acid nyo, fixative siya and a decalcifying agent at the same time. Used for minute bone spicules. So we're done with the use of acids class. Another method for decalcification is chelation. So chelation, you would use EDTA, combining it with calcium, which would form an insoluble non-ionized complex, recommended for immunohistochemistry, enzyme study, and EM. Inactivates alkaline phosphatase activity. Is very slow class, takes 1 to 3 weeks for small tissue. 6 to 8 weeks for dense cortical bones. Produces minimal cell and tissue distortion, permits excellent staining, and inactivates alkaline phosphatase activity, which can be restored by magnesium chloride. Then another method class is ion exchange resin. Now, si ion exchange resin class would require 1 to 14 days for decalcification to occur. Ammonium would form polyestyrene resins which would attract calcium from formic acid containing decalcifying fluid. Resin may be reused by eluting the bound resin with the use of N10 hydrochloric normal, minimal cell and tissue distortion. Take note, class, that it would allow excellent staining of the tissue, but this is a very slow decalcification. It takes 1 to 14 days, not for urgent biopsy. Then we have your electrophoresis. Ang electrophoresis, if you remember, is used to separate ions based on their size. So calcium salt plus hydrochloric acid would produce calcium, transferring to the cathode. Calcium would migrate to the cathode. Now, take note of the factors affecting decalcification: concentration and volume of decalcifying agent, temperature. Recommended temperature is room temp, which is the optimum temperature of 18 to 30 degrees centigrade. So you have to do decalcification class sa room temperature set at 18 to 30. Agitation class accelerates decalcification, follows the principle of faster diffusion. Then you have to also consider the tissue size and the thickness. Recommended fluid tissue to ratio is 20:1. Thicker and longer slices would require longer decalcification. Ideal decalcification time class is 24 to 48 hours, 1 to 2 days. Now, how would you check for the completeness of decalcification? There are different methods. The first one is via physical or mechanical. Touching, bending, squeezing, pressing, and pricking are examples. This is less accurate or the least accurate method because it is subject to artifact formation. Then we have your radiologic via X-ray, which is the most accurate because it can locate areas of microcalcification. Opaque appearance indicates completeness of decalcification. Sadly, this is a very expensive method, not recommended for mercury fixed tissues because of its natural radio opacity. Then chemical, such as the use of calcium oxalate tests. Calcium in the decalcifying liquid is tested. The decalcifying fluid is to be prepared with distilled water. Tap water is not used because it may contain calcium that would lead to a false positive result. Involves resumptive and confirmatory tests. Then we have your post decalcification. This is the process of neutralizing chemically or removing the acid from the tissue. Tissue is washed in running water. So you need to do post decalcification class for smaller tissues for up to 30 minutes. And if it's a larger tissue or a larger sample, you need to do post decalcification for up to 1 to 4 hours. Then there's what you call chemical neutralization. Neutralize with saturated lithium carbonate or 5 to 10% aqueous sodium bicarbonate for several hours. Then do not place EDTA decalcified tissue directly in 70% alcohol. This will cause residual EDTA to precipitate in alcohol and within the tissue. Tissue softeners may sometimes be required, such as Moliflex, 2% hydrochloric acid, 1% hydrochloric acid, and 70% alcohol 4% aqueous phenol solution, and Pereni's fluid would act as a tissue softener and decalcifying agent. So that ends your lesson 2, decalcification.